Hello, everybody, and thank you so much for joining us this afternoon. My name is Paula Basili, and I lead up communications at the Center for Geospatial Solutions, which is one of the organizations that's part of the Internet of Water Coalition. And we are really excited to welcome everybody to our webinar series. So for those of you who might be new, this is our regular scheduled programming. We host these about once every month or so. And it's a chance to showcase all of the great work being done by the organizations out there who are really bringing an Internet of Water to life. So water data discovery and modernization projects, tools, case studies, and the like. And we are really excited to be joined here today to talk a little bit about a new tool, the Geoconnex Explorer. But before we hand things over to our speakers for this session, I just want to remind everybody of a little bit of housekeeping. So first of all, these sessions are being recorded, and as with all of our webinar series, they will be available for you to watch, rewatch, and share with your colleagues on YouTube, on our YouTube channel. So give us about a few days or a week or so, and we'll get that video right up there, and you'll be able to access it however you like. And the second question and the important thing to keep in mind is if you do have questions, please, we want to hear them. Submit them via the Q&A function down below. It is the best way for our presenters to be able to see, track, and keep note of any questions that come in. We will be saving all questions and addressing those at the end of the presentation. So if you do ask a question, just please stay tuned for the end, and we'll be sure to get it over to you. Okay, and so today, like I said, I'm excited to welcome our speaker for today's session. Ben Webb is a software developer at the Center for Geospatial Solutions, which is the organization that helped create the Geoconnex Explorer tool. And so, Ben, welcome. I'll be handing things over to you and for you to teach us all about this great new resource.
Thank you so much, Paula.
Yeah, no worries.
So without further ado, I would like to thank everyone for joining this Internet of Water Coalition webinar. Today we're going to be talking about the Geoconnex Explorer, which brings river data to your fingertips. And my name is Benjamin Webb. I'm a software developer here at CGS. So today we're going to be talking first about what CGS is and how we fit into the whole Internet of Water picture. Then we're going to be talking about the Water Data Discovery Challenge. Then we're going to dive into what Geoconnex Explorer actually is. And finally, we're going to close out with what else is possible. So without further ado, what is CGS? So our mission at CGS is to enable data-driven decisions for the greater good of land, water, and people. We work across sectors to transform fragmented, hard-to-use data into integrated insights that's accessible and actionable. So the Center for Geospatial Solutions was founded in 2020 at the Lincoln Institute of Land Policy. And whether climate change, housing, broadband, water conservation, decision makers are being asked to ask faster and more transparently. And information is a key step on community's anecdotal experience, providing hard evidence needed to make the informed data-backed decisions that we're talking about for the future. The Center for Geospatial Solutions is the technical engine behind the Internet of Water Coalition. The Internet of Water originally started at Duke University, and in March of 2022, CGS and the Internet of Water Coalition formally joined forces to steward the next phase of the project. In its role as the steward, CGS focuses on scaling the adoption of Internet of Water technology and services. By furthering the digital infrastructure necessary for an Internet of Water, CGS is helping transform the water data landscape. And so when we're talking about the water data landscape, what are we really talking about? And really what we're talking about is the Water Data Discovery Challenge. And when we're talking about what is the challenge? One of the first things I tend to turn to are the Internet of Water principles. So these are principles that were originally created in 2017 at the Aspen Institute meeting, which founded the IoW Coalition, and then revised again in 2021. The first principle I really think that's important to focus on is commonly accepted data, metadata, and exchange standards should be adopted by water data producers to promote interoperability, efficiency, sharing, equity, and secondary uses of data. Far too often, new standards are created and then abandoned, and the ability for secondary uses of data dies out very quickly. And the second one is federated distributed systems of interoperable public water data generally provide scalability and flexibility required to meet the diverse needs of producers and data. So in this, data is really best presented by the original producer to maintain as much provenance as possible. And there's really too much data when you think about all of the data from a local to a state to a federal level for one person or thing to really aggregate every single bit of data. And that really comes to a front when you're looking at the entire water data ecosystem. So forgive me if I did not include your specific organization. The context of the problem is that there are far too many to ever focus on or to really capture into one. And so you have federal agencies like the Army Corps of Engineers, Environmental Protection Agency, USGS, USDA, and NOAA. And then you have smaller state level agencies like state level EPAs, natural resources, and water service agencies. And then finally, you also have academic institutions like COASI, community science organizations like the National Water Quality Monitoring Council. You have individual private vendors like KISTers, and then you also have municipalities that are producing data. So there's just so much data out there. The goal of Geoconnex and the Internet of Water is to really break down the barriers in information between all of these individual institutions. And when I think about that, I think about kind of three main components that we're talking about. So today, Geoconnex is composed of an open centralized knowledge base for all index data. This is really the backbone of the Internet of Water, and it exposes data, water data within a knowledge graph. The second side of Geoconnex that I spent a lot of time working on is a suite of software to equip organizations with modern data infrastructure. So powered by open source development and designed to be adaptable, transparent, and community driven. Open source software tools allow data providers to focus more on data and less on the tool and costs associated with sharing. And finally, a documentation center to provide developers with the technical details of the Geoconnex system. This is a detailed guide and on how-to implementation of how you can contribute your data to Geoconnex. And so once you've hopefully contributed your data to Geoconnex, it would start to appear in Geoconnex related tools like the Geoconnex Explorer, which is probably what a lot of you actually came here to learn about. So I'm glad you bear with me as I, one, took you through the adventure of a broken Zoom, but also explained the context of the problem, why I'm here, and what we're working on. So Geoconnex Explorer and Geoconnex itself can be explored by anyone from a curious user to a super user. Someone who has tons of GIS experience to someone that is really, this is their first time on the internet. Think of your grandmother, if they're old enough. But Geoconnex Explorer specifically is really trying to focus on a tool that is making Geoconnex accessible to a curious user. So someone who doesn't really know how to code, so it provides a no-code way of exploring. It's still usable by savvy and super users. It's not meant to be the only way to access data. It is meant to be one way to access data within the entirety of the Internet of Water and Geoconnex itself. And so that brings us to the Explorer tool. So the Explorer is a set of all of the main stems and hydrologic basins in the United States served as OGC API tiles or Mapbox vector tiles. So that's how we're able to load all of these main stems super quickly. We offer free versions of HUX 2 through 10, as well as various different other reference layers for people to index their data to. The Geoconnex Explorer, though, is really about data that's been indexed to rivers. So as a new user, when you load in, you can first, try to reduce the number of rivers. So if you only want to see the major rivers in the US, you can turn that on. But to have a slightly less visual overwhelm, you can also choose based on how large the rivers are, and they're categorized. But the general purpose of this tool is to really find a river or main stem of interest and to learn what data exists about it and who's collecting data, without needing to know any specifics of the data, of the river, of anything else. So for sake of the fun, I'm going to look up the Sacramento River. And so as you can see, there are actually appears to be 5 Sacramento rivers in the United States. There's the main Sacramento River, and then there are a bunch of smaller ones that feed into it. But we're really interested in the Sacramento River. So it is 880 kilometers, and there are 336 sites with 28,000 data sets measured along the river. So by collecting the river of interest, we're able to see all of these sites loaded onto the Sacramento River and where they are. So we can see here that there are a vast majority of wells or stream gauges, which kind of makes sense because we're looking at something along a river. And then when we think about what data is measured, we see that there's a pretty wide range of data where even the most common site only constitutes 1% of the total data. So, there are a wide variety of data being collected here about the Sacramento River. And the way the view here works is it's actually limited to the specific scope of the map frame. So if we're really just interested about the data in the Sacramento River, and what's important to note here is data can be about a river, even if it's not directly on the river. That is how water and hydrologic basins work, where these monitoring stations are directly related to the Sacramento River. But as you zoom in more and more, you can start to see that you can really drill down into what you're actually looking at and where there are stations. And if you were to select any individual station, you can even see what stations are there. So here are 2 USGS monitoring gauges, and they're collecting 350 different parameters. The secondary view you can use is the table view here. And so the table view just enumerates out all of those 350 data sets into site and data stream specific. So right now we're looking at just the 2 or just this visible site here, USGS 3835, 38121, 302, 109. And it is something we pulled from Water Quality Portal. And you're also able to go through and see all of the variables that that are measured about it. You're able to go to the standards-based monitoring location page, which is where we were able to crawl the data. You are able to go to the URL, which is the Water Quality Portal, National Portal, which is the source information of this page. And then you are also able to go in and actually download the data directly. So Well Explorer is really meant to be largely a data discovery tool. There's not quite an ability for bulk download, but if you found any particular combination of feature and site of interest, the Explorer allows you to figure out the provenance of the data, download the data, and ask more questions of it without necessarily needing to go into any coding. And this can be done for any river in the contiguous United States. So, we encourage you to go in and look for what type of data is being collected about your local stream gauge. So switching back to the website or the agenda, that was the biggest and briefest crash course in the Geoconnex Explorer that I could give. Hopefully the tool is mostly self-explanatory. I want to give a huge shout out to a member on this call, John Solomon, who's our front-end developer, who's put a lot of work in to improving the user experience. If there are any questions in the info bar here, we encourage you to open a GitHub issue for any questions, concerns, anything else. So just go to the question here and then submit a GitHub issue. And we'd love to hear from you. But Geoconnex Explorer isn't the only way to access Geoconnex. So like we talked about, Geoconnex Explorer provides an access mechanism for a curious user. But what does that perspective look like for a super user? So speaking for myself, how could I create a tool that maybe looks like Geoconnex Explorer? Because it's actually quite simple. And we're only asking one Sparkle query of Geoconnex. For the sake of brevity, I'm going to assume that you guys know what Sparkle is. I know most people don't. That's fine. It is a way of sending queries over the internet for a more complicated request. So what's actually happening under the hood? So we host our knowledge graph at graph.geoconnex.us. And on the left side here, you're seeing the Sparkle text. And on the right, you're seeing the output map that our documentation playground is able to generate. So what you're looking at and what creates Geoconnex Explorer is given a selected mainstem with URI reference 1 is the Sacramento River. Show me any location that is somewhere near the linear element of that mainstem. So show me a location on the Sacramento River and return that geometry. And from this simple 5-line query, we're able to generate all of the sites that are on the Sacramento River. And that doesn't look all that different than the Geoconnex Explorer because it's the exact same query, except in the Explorer, we're also asking to expand beyond just the locations. We're asking what data sets are those locations collecting data about. But again, this is only one query. It is the same Sparkle query, just depending on the mainstem you're asking about. And with Sparkle, you can ask any number of questions. So say you aren't just interested in the Sacramento River because the Sacramento River doesn't exist in isolation. There are a bunch of rivers that flow into it. And luckily, it flows out to the ocean. So we can pretend that there's nothing it flows out to. But what if you want to know what rivers are upstream of the Sacramento River? Using a recursive query here, we're able to say, show me all rivers that are at any point have the Sacramento River as its downstream component and load that as text or as geometry. So all of this is saying is anything that says that I will eventually flow into the Sacramento River, show it as a river. And you can then combine this with the previous query to say, what about all monitoring locations on all upstream rivers of the Sacramento River? So you combine the first two queries we looked at, and now you're looking at all monitoring locations that could feed into any point in the Sacramento River. And you can still use any of the follow-up, expanding data sets and everything that the Geoconnex Explorer does to actually dive deeper into this data. But the key is that all the Geoconnex Explorer is doing is asking a single question. And within the last 3 slides, I've shown 3 different questions that Sparkle can answer that, Geoconnex Explorer doesn't really try to. But you can ask other questions. So say you are working for the state of California and you're trying to do a campaign on the Sacramento River. And so you need to figure out, what counties do I need to go to figure out what data they have and how do I aggregate it? With a knowledge graph, you can very easily say, show me all counties that intersect with the Sacramento River that are counties. Because it may be important to look through your data, not just on a hydrologic boundary, not just on an administrative boundary, not just on a social boundary. So the goal of Geoconnex is to allow you to present your data and access it through a variety of access mechanisms, thereby allowing, an infinite number of questions to be asked. And I think that is the most important thing here, where you can ask any question of the Geoconnex graph of all of the data we've collected. And so if you were to go to docs.geoconnex.us/playground/sparkle, you would be able to explore different Sparkle queries. So this is our documentation website, docs.geoconnex.us, and in our playgrounds we have a demonstration Sparkle query helper, because a lot of people don't necessarily know Sparkle. So we have these pre-formatted dataset queries. So this is the longer, more enumerated version of the actual Sparkle query used to make the Geoconnex Explorer run. So instead of just getting the monitoring location, we're also getting the temporal coverage of the variables and more information about those variables. But we're able to run this query, and this is querying the live Geoconnex graph. And once we've loaded our results, we can put it on a map. And that is exactly how I made all of the map all of the pictures used for this presentation. So you can go directly from a query to the visual manifestation of it on a map. And you can really ask an infinite number of questions. We hope to continue to populate the Sparkle query helper with more and more relevant queries. So users who aren't experts in Sparkle are able to begin to ask more questions of the Geoconnex graph. And with that, I would say, are there any other questions? Thank you very much.
Thank you so much, Ben. This was an awesome walkthrough. Really appreciate you taking the time. And thank you for everybody who's submitting questions in the Q&A. Remember, if you do have a question, that's the best place to jot it. So, but maybe just to kick things off, I would love, there's a few questions in the chat sort of around data provenance, right? So Ellen Galinsky asked, like, how do you know the source of the data you are looking at? And specifically, is each data source, are you looking at each data source separately, or are they combined for the same date and location within the Explorer? So I'm wondering if maybe you could talk a little bit about that, kind of the idea of data provenance, how Geoconnex is really oriented around that, and then more specifically, how the Explorer itself can help you get that information about,
So the principal goal of Geoconnex Explorer is to make it possible to discover data without necessarily needing to know the provenance source that you're referring to. So the goal is to make it so that you don't necessarily need to know, all of the different federal and state agencies that are collecting data. But it is important to provide that provenance when it comes to the presentation of the data. So although when it comes from a query side, there's not necessarily control, and inside Sparkle, you can actually add a filter for, show me data from this provider. Inside the Explorer, there should be enough provenance collected about any individual location that you can figure out and, drill back down to where it was actually sourced from. So I would say if you go and look at the Geoconnex Explorer, that is how you get to, one of these pages, because everything in Geoconnex should be tied back to the original source system and the original data producer.
Awesome. Thank you. That's really helpful. And then what about kind of improvements, right? So Ashley DeCensi writes, for example, that she noticed kind of a mislabel on the area in which she works in. She works in the Chattahoochee River Basin, but it's mislabeled as the Apalachicola. I apologize for that butchering, I'm sure, of the pronunciation. How, so one, I know you mentioned, an easy way to kind of log questions or flag errors was that kind of GitHub link. Is that still the best place to log those? And also just more generally, I guess, can you speak a little bit about like data quality, I guess, within the Explorer and within Geoconnex too?
Yeah. So I believe, at least in the, I am unfortunately not a hydrologic expert, so I am talking well outside my domain. What we're talking about and demonstrating here in the Explorer is the HUC2 level, which should be including the region level. And as far as I understand, that would be a different level than basin. Kyle, feel free to answer.
Yeah, and for those who may not know, we also have Kyle on the line. Kyle is, do you want to introduce yourself quickly before you jump in?
Yeah, hi folks. My name is Kyle. I'm the director of the Internet of Water team here at CGS, and um, just yeah, this has been sort of a labor of love of mine and my whole team for a few years, and it will hopefully continue to do that. So in terms of the basin, yeah, so I'm not sure exactly what Ashley meant in terms of the basin being incorrectly labeled. If it was the HUC2, then we're just taking the label from USGS, from the watershed boundary data set. If it's the actual river is mislabeled, that can happen because of the way we have automated the collection of and the generation of these river segments. And so, yeah, we encourage just the creation of GitHub issues to indicate those errors and a source for the correction, for sure.
Cool, thank you. And we'll drop that link down in the chat as well, so you have it handy. Now we have a couple more questions. Gregory Gerhardt asks, are there any examples of, or do you have thoughts on using this tool to go deep on a curated set of water data? So like one topic or use case zone, for example. He's saying, in my mind, this example is more wide. So really kind of thinking about more broader application.
I could try to answer that, Greg. Yeah, this was our first foray into building a real UI. Like Ben said, an infinite number of questions can be asked, and so we're open. We're absolutely open to different specific use cases that are more deep. I mean, one that I've imagined, but we haven't implemented, and depending on the state, it would be possible to do something like, I wonder which water quality stations are within 10 kilometers upstream of a collection of water intakes for water service for public water systems that I care about. And maybe those public water systems are you've selected by some criteria like census demographics. So that could be an interesting sort of environmental justice type use case. But we encourage folks, we would love to get those kinds of deep use cases that we can sort of think through how we would build capabilities and features around.
Yeah, I would say that's exactly correct, Kyle. And really the purpose of the Geoconnex Explorer is to answer the question of what data is being collected about my river or main stem of interest. And that's really only one question. And when we're thinking about the knowledge graph and how we're trying to aggregate the data, there are an infinite number of questions. And so it's just making sure that we have, a very finite driven use case for what question we're trying to answer. And I'm more than confident it would be possible to build an example query for how that would work.
Very cool. Thanks. This is a great start. Great first place to start. Scott Ensign asks, are wells or other site types not located on a waterway linked to a river based on watershed boundaries or some other topography-based flow path? So a little bit of a turn back to the Explorer and what it is actually displaying.
Yeah, so when we're talking about the Geoconnex Explorer, we're not even necessarily talking about geospatial intersections. So all of the gauges and monitoring locations that you'll see are directly referenced to a specific main stem. So on that main stem, it has identified, whether it's a well adjacent to a main stem or a stream gauge literally on the main stem. It is physically associated with that main stem. Something we're talking about, and what you can see in the counties-based query, is that there are ways to do geospatial intersections. So instead of doing just, show me things that have been already assigned to be associated, you could say, within my known HUC boundary, what data exists within that. And one of the things that we're actually thinking about in the future is more and more ways to interlink data. So making it easier for individuals to associate their data with a given, urban area, public water system, county, HUC, state, the list goes on. And those are all reference features that we host.
Very cool. There is a question kind of about integrating this tool, right? And so Taylor Christian asks, we would like to include this data in the Texas Water Data Hub. Can you talk about when using building queries, could you format the query to format the results in a certain way? For example, a CSV?
You certainly could. Sparkle is kind of just a type of query interface. So, similar to HTTP or, all of these other sort of internet protocols, it can return anything. The Sparkle language, I believe, has a defined response schema, but it wouldn't be too complicated to directly download that as CSV. Tabular format is one of the very common outputs from the Sparkle query. So if I go back here, it's going to look a little bit wonky because this includes the table, but all Sparkle data comes back as a table. And what the Sparkle engine is able to just parse this as either a flat table or something with geospatial relation, which is why we're able to put it on a map.
Nice. So the download from the Sparkle query would look like be formatted in a table, which is great.
Yeah, and then you could go in and download that as a CSV file.
Okay. And we have another question. I know I think we've been curious about this before, right? Because Geoconnex in general references so much, and the team is always always trying to add more and add new information to it. So I guess a two-part question. One is just, where is the list of data sources that are referenced by Geoconnex and, available through the Explorer? And more broadly, can we get a status update? I think maybe Kyle, you'd be able to answer this around USGS data specific, how it's represented, and kind of what the status is of incorporating all those other major databases. That's a question from Scott Ensign specifically.
I can answer that, Ben, if you want. So thanks, Scott. So what is, as far as USGS is concerned, what's in there is everything in the instantaneous value service, as well as the WQX 2.2, so sort of the older endpoint, or not WQX, sorry, the water quality portal, which includes WQX. We would like to move to WQX3. It's sort of in the pipeline to get truly up to date on everything that's in the water quality portal. In terms of summarize the status of, that's a great ask for a feature that maybe, I think the Geoconnex Explorer, when you pick a river, there's a field called provider that you can filter by that will show. But we'll be getting in a lot more data sources fairly shortly because of some other projects we're doing with federal and state agencies. And And so I think it might be cool, maybe put a pin in that idea, to have like a dashboard of everything that's currently in the system. But we don't have something like that right now. You would sort of have to list the unique providers. And there's a query for that maybe we could, as the first step, we can build an example for.
Nice, thank you. Anything to add to that, Ben?
Yeah, I would just add to the second part of your question, Paula, about where can you discover what data already exists in Geoconnex. There are kind of two options I would suggest. So the first, if you're GitHub savvy, we organize Geoconnex under this concept of a permanent identifier, and all permanent identifiers are organized by organization and then individual mapping. And what this is used to do is generate a sitemap index of all data within Geoconnex. So admittedly, sitemaps are meant to be crawled by bots, not by humans. So it's probably going to be pretty abrasive to go and look through. But if you wanted to look at all of the outcomes from the selfie experiment, you could go through, and here's the list of every single selfie location that we've included in Geoconnex. If you wanted to look at the USGS ones, let's see. We could look at the USGS hydrologic units here, and we're only showing 50,000 at a time. So here are all of the USGS hydrologic units, and there's a long list of sitemaps that we've included. So there's a lot of data, too much for me to quickly and comprehensively show it. But that is actually an interesting tool we could totally build out as one that presents this in a much more readable, parsable way.
Awesome. Thank you so much. Okay, I think that wraps up our questions. Ben, Kyle, any kind of like final words, parting thoughts for the group?
I'll say two ththings. Again, if you look at this and are like, I wish it would do this, send us that. and then the other thing is, one of the things this definitely, we have an idea for it to do is, for those of you who run data catalogs yourself, like Taylor's question, one of the major capabilities we want to be able to do is to allow any data catalog to discover data from any other data catalog that's participating in this system. And that's what that API, the Sparkle API that Ben showed, would allow you all to do. And possibly even outsource search functionality for your own metadata catalog to our infrastructure. That's a major kind of use case we imagine. So I'll just leave those two thoughts there for the nerds among you. Ben?
Yeah, I mean, I would say that the Geoconnex Explorer is really only asking one question of the data we have. And so I would love to know other, hydrologic questions you would think to ask. So both if you have a question of why isn't this there, or could I ask this? Is it possible? We welcome all of that because that is what Geoconnex is here to do, try to answer those questions.
Yeah, 110%. Thank you, Ben. Thank you, Kyle. And that'll be my plug too for joining the Internet of Water Coalition channels. So both on LinkedIn, X, those are great places to also share your feedback. We'd love to hear from you all. And it's a great place to stay tuned for more of our Internet of Water events, webinars, and activities. So if you haven't yet followed us on social, please do. And we hope to see you guys soon. Otherwise, thank you everybody so much again for spending your afternoon with us. And thank you again to our speakers, presenters, Kyle and Ben. Really appreciate you joining us, and thanks for taking the time.